Hi, and welcome back to our channel Neurabytes. My name is Navjinder Virdee, and in this lesson, we will learn how to delete nodes from a linked list. We will learn about two deletion operations. Number one is PopFront. It removes the node at the front of the list. And number two is PopBack. It removes the node at the end of the list. Let us start with the PopFront. Let's say we are given the following list. After applying the PopFront function, the node 30 will be removed from the list. Now head refers to the node 10. Let us see how it works. We only need to perform one step for PopFront. Just change the head reference to point to the second node instead of the first, which can be done by head is equal to head.next. Let's say we are given the following list. After performing this step, the head will now refer to the node 10 instead of the node 30. Since there is no reference left for the node 30, it will automatically get deleted by the garbage collection. So here is our final list after PopFront. Now let's implement the PopFront. In the previous lesson, we implemented the node class and defined the head node. We also implemented the insertion operations. Using pushFront, we inserted 10, 20 and 30. And using pushBack, we inserted 40, 50 and 60. We also learned about the time complexities and the traversal function. If you haven't seen the last lessons, please check them out. I have provided the links in the description below. Now let's implement the PopFront. So first, if the list is already empty, then we don't need to do anything. We will just print that the list is already empty. Otherwise, if the list is not empty, then we will perform head is equal to head.next and we will return the new head. That's it. Now let's check it out. Let's first print the initial list. Then we will perform the PopFront, which will remove the first node of the list. And then we will print the updated list. So, as you can see, the initial list started with the node 10 and the updated list started with the node 20. Therefore, we have successfully removed the first node using PopFront. Now, let us learn about the PopBack. Let's say we are given the following list. After performing the PopBack, the last node will get removed, which in our case is node 30. Now the last node is node 15. Now let's see how it works. The first step is to create a temporary node and assign head to it. Let's say we are given the following list. Now both the temporary node and the head are referring to the first node, that is node 10. The next step is to traverse the list and get to the second last node of the list. So, while temp.next.next is not equal to none, that is, we need to check next to next node. If we only check temp.next is not equal to none, then we will reach the last node instead of the second last. We will move to the next node. Initially, we are at node 10. The next node is 20 and the next.next is 15, which is not equal to none, so we will move forward. Now we are at node 20. The next node is 15 and the next.next node is 30, which is also not equal to none, so we will move forward. Now we are at node 15. The next node is 30 and the next.next is none. Hence, we have reached the second last node. So we can stop the while loop now. Now the temp is referring to the second last node. The next step is to change the temporary node's next pointer to none. Since there is no reference left for the node 30, it will automatically get deleted by the garbage collection. And this is our final list after PopBack. Now let's implement the PopBack function. The case 1 is when the list is already empty. Then we do not need to perform anything. We will just print that the list is already empty. Now the case 2 is when the list contains only a single node. Then we will just change the head to none and return the head. The case 3 is when the list contains more than one node. Then we will create a temporary node and assign head to it. And then we will traverse the list and get to the second last node. Using temp.next.next is not equal to none. We will keep moving forward. Once we reach the second last node, then we will change temp.next is equal to none and return the head. That's it. That was our PopBack function. Now let's check it out. First, we will print the initial list. Then we will perform PopBack function. And then we will print the updated list. So as you can see, the initial list contains 60 as its last node and the updated list contains 50 as its last node. Therefore, we have successfully removed node 60 using PopBack function. Now let's go through the time complexities of these operations. The time complexity of PopFront is constant time. This is because we only changed the head reference. And the time complexity of PopBack is linear in terms of the length of the list, where n is the number of nodes in the list. This is because we need to traverse the list and get to the second last node of the list. Thank you for watching. In the next lesson, we will go through some interview coding questions for linked lists. If you liked the video, then please like, subscribe and share. And I'll see you in the next lesson.